In this video we are going to solve some exercises related to the Pythagorean theorem. First, we have two basic exercises, one where we have to find the hypotenuse and one where we have to find one of the legs. So let's do it. Since in this one we want the hypotenuse, according to the Pythagorean theorem, we know that the hypotenuse squared is a result of the addition of the two squares of the legs. So 9 squared plus 40 squared. The hypotenuse squared will then be 9 times 9, which is 81, plus 40 times 40, which is 1600. Okay? The hypotenuse square is then 1681. Okay, and finally, for that one, we have to find the square root. Because remember, here's a square, the opposite would be the square root of that, 1681. And so let's do it. Let me find a calculator. We can do it by prime factorization, but let's be quick. So the square root of that, according to the calculator, actually let me pull this here. Square root of 1681, the square root of that is 41, is exactly 41. Okay, let's confirm. What would it be 41 times 41? That one. So yeah, the hypotenuse is 41. Now here we want a leg. Okay, and how do we know it's a leg? Because remember, the hypotenuse is always opposite to the 90-degree angle, which happens here. So the hypotenuse is 25. Even if the triangle is not in a usual orientation, it doesn't matter because we can identify what are the legs and what is the hypotenuse. So this one is the hypotenuse. Remember, always opposite to the angle, to the 90-degree angle. So 25 squared should then be 7 squared plus m squared. Okay, but you know this trick. If we want to find the leg, you can actually find it by subtracting the other two values squared. Okay, so the leg squared would be 25 times 25, which is 25 times 25, 625, minus 7 times 7, which is 49. Okay, let's do it. 625 minus 49. Okay, so this becomes a 1, this becomes 15, and 15 minus 9 is 6. 1 minus 4 is not possible, so this becomes 5, for this to become 11. 11 minus 4 is 7, 5. Okay, so m squared is 576. If we want to find m, then we will have to find the square root of that one. And once again, let me pull out the calculator. The square root of that is exactly 24. So m is 24. Okay, now we move to this point. Okay, and it says, determine whether the triangle given by the following measurements, so this measure, and this measure, is a right angle triangle. Okay, we have to justify it. So how do we know it? Like, if this were a right angle triangle, then the Pythagorean theorem should work in it. What do I mean? If we can imagine a triangle with these measurements, like this. So let's say 8 centimeters, 15 centimeters, and 16 centimeters. And 16 is the hypotenuse because the hypotenuse is always the longer. Then, if I make 8 squared plus 15 squared, I should get 16 squared. Let's confirm. First of all, what is 16 squared? Okay, let's do it. 16 by 16. 256. Okay, and what is 8 squared? That's 64. And 15 squared, 15 times 15, 225. And what is the addition of that? You already can see that it's not 256. It's 289. And it's not working, okay? Because these two things should be equal. They are not. So it is not a right triangle because the Pythagorean theorem does not apply with these measures. So it's not right angle triangle. Okay, for the third problem, this one is a little bit more complicated. So please try to follow my explanation as carefully as possible. I am going to try also to explain it as easy as possible. A group of students from an IB school is planning a camping trip. They need to determine the length of a diagonal rope that will connect to corners of the rectangular tent, which is from D to F. So from here to here, this diagonal segment, this is the rope. We have to find that length, okay? But a tent is a 3D figure, and it's described to us that it's rectangular, so it has a rectangular prism shape. We have to find this. We can do it applying the Pythagorean theorem, but we have to be careful because this diagonal length goes from one corner to the opposite corner in the opposite side. Like, for example, this one is down close to us and this one is up in the further side. So we have to be careful because this is the diagonal of a right angle triangle. Yes, the hypotenuse. But which is the triangle? And if you see, I am going to mark it with blue color. If you see this one is the the hypotenuse of this triangle which goes inside the tent, okay? Here's the right angle triangle right angle that is inside this triangle, inside the tent. So let's see if we have the measures of it. We have this one, which is 4. This measure is 4 because like this is exactly the same measure than this, which is 4. But we don't have the measure of this. Nevertheless, we can find it. Okay? We can find it, and let me mark it with another color, because this measure is the this length, this line, is the hypotenuse of this triangle. Okay? If you imagine this triangle, which is like half of the bottom face, you will see that the measure that we want is the hypotenuse. So let's call it, let me call it with also color this one would be, let's call it x. So we have to find x, but x is the hypotenuse of the red triangle. So x squared should be equal to the addition of the square of this leg, which is 2 squared, and the square of this leg, which is 6. Look, this is 6, therefore this is also 6. So x squared is 2 squared is 4, plus 6 squared is 36. So x squared is 40, and x is square root of 40. Let's find it with the calculator, but it will give you an approximation because it's an irrational number. So 40, and the square root of that, look, it's 6.3245 approximately. So let's leave it with 6.32. Now we can find this hypotenuse. Let's call it y. Okay? So now y squared from the Pythagorean theorem, this is the hypotenuse, should be the result of this leg squared, which is 4 squared, plus this leg squared. So this is approximately 6.32, but it is exactly the square root of 40. So remember, if you can have or write the exact value, use it. It will give you a closer result in the end. So this leg is square root of 40. Let's discard the decimal version for now. This is a square root of 40. So square root of 40 squared because of the Pythagorean theorem. Now this squared plus this squared. There you have it. So y squared is 16 plus, like 4 times 4 is 16. Now what is square root of 40 to the second power? Remember, we are doing two opposite operations, so it's like we are not doing anything, like, because this power 2 cancels with this square root because they are opposite. So actually we are left with a 40. So y squared is 16 plus 40, which is 56. And y is the square root of 56. Now, let's find it. Square root of 56 is approximately 7.48. So that's the result. The square root of 56 or 7.48 centimeters. Okay? Well, it should have been in meters now that I think about it. Anyway. Now, what happens if instead of using a square root of 40, we use 6.32? Well, then when you make it squared, you won't get exactly 40, but a close result to 40. So let me show you. 6.32 times 6.32. You see, it's not 40, it's approximately 40. It's close because it was an approximation. So in the end, we won't get exactly the same. And even though it would be close, it's better to only use approximation at the end. If you are able to have the exact value, use them. And finally, the last point, criterion D. Well, two trains leave the same station. So in A, we have to make a diagram to scale representing the situation. So I am going to do it in this grid. So let's say that this point is the station. And I am going to use the red color for train A. So because two trains leave the same station, train A heads north for 40 kilometers and west for 30 kilometers. So let's say that each square represents 10 kilometers. So north 40 kilometers would be approximately like this. Okay? Then west, remember, east is to the right, west is to the left, and that is 30 kilometers. Excuse me, let me do it again. Yep. So here's train A. Fine. Now, train B also goes or leaves the same station, heads east, so in this direction to the right, for 50 kilometers. So let's do 5 squares that represent 50 kilometers. Okay? And then south, which is going down, for 25. So it's approximately 2 squares and a half. More or less here. So here would be train B. Okay, we already did A. Now we have to find the distance between the first train and the station. Like the distance, the shortest distance is always a straight line. So we want to find the straight line between here and here. And since with this direction of that the train had, we form a 90-degree angle here, then for B, we would just need the hypotenuse of this right angle triangle. So let's redraw it here. Excuse me. And this would be 40 kilometers. This would be 30 kilometers. And this would be, let's say, x. So again, Pythagorean theorem. X squared is 30 kilometers squared plus 40 kilometers squared. That would be 900 plus 1600. So x squared would be 250. No, excuse me. 2500. And x is the square root of that. Which is 50. Okay, so it's 50 kilometers. Okay, then we have to find the distance between the second train, which is B, and the station. So same thing. Okay, let's redraw this triangle. So that would be something like this. This would be 50 kilometers, this 25 kilometers, and this, let's call it y. So y squared is 50 kilometers squared plus 25 kilometers squared. 5 squared is 50 times 50, which would be 2500 plus 25 times 25, which would be 625. So y squared is the addition of those two. That would be 3125. And y is the square root of that. Let's find the square root of that. approximately 55.9 kilometers. Okay, so 55.9 kilometers. Okay, we already made C. Now, find the shortest distance between the two trains. So remember, always the shortest distance between two things is a straight line between them. So let's do it with another color. Because you will notice that it's not the addition of these two things. No, that's not the shortest distance. The shortest distance is this one. And how can we find the measure of that line? So if you realize this is actually the hypotenuse of another right angle triangle. Let me make it a little um, thicker so that you will see the green triangle that I'm talking about. Yeah, I'm talking about this triangle. So what are the measures of this? Look, this was 50 and this was 30. So it's actually 80 kilometers. And this one, this was 40 and this was 25. This is 65 kilometers. Okay, now we can find that distance. I am going to do it here, okay, because basically I don't want to switch slides. And the space is enough. Okay, so this is 80 kilometers and this is 65 kilometers. We want to find, let's call it W. Okay, so W squared would be 80 squared plus 65 squared. Okay, let's find what is that. W squared is 80 times 80 would be 6,400, and 65 times 25 times 65, let me do it, is 4,225. Now W squared is the addition of these two, which is 10,625, and W is the square root of that. Okay, let's find it. Excuse me, I wrote it wrong. Now square root of this, approximately 103.07 kilometers, or 0.8 because we have to round. So the shortest distance between the two trains is approximately 103.08 kilometers. Okay, that's for D. Now, point E is a little bit more complicated. So actually, I will need to, excuse me, I will need to make another diagram in another slide. Let me return this. Okay, and let's actually make again the drawing because we will need it. So this is the station. So basically, let's draw it again. Train A goes north 40 kilometers and west 30 kilometers. This is A. And B goes east 50 kilometers and south 25 kilometers. So that's B. But now, let's see what here is written. Train A traveled 20 kilometers more in the same direction. So 20 kilometers more in the same direction. So let's represent it. So this is actually 50. Okay? And train B also traveled a certain distance more. Like we don't know. We don't know. Okay? It's unknown. Now the shortest distance between both trains is 140 kilometers. So if we make something similar to the previous point, the distance between them should be 140 kilometers. And we are being asked to calculate the distance that train B has traveled in total. So train B has traveled this and this. So this is a multiple step problem. Because knowing that, we need to find the missing distance that B traveled more. Okay? So let's do it. Let's create a triangle. Okay, similar to that one. Okay, so this is 140 and this is, look at this triangle. Look at this triangle. Yeah, it's this one. So 50 and 50. 100 kilometers. And this one, we don't know how much it's in total. We know it's a little bit more than 65, but we don't know this part. So we don't know the total. We know that there's a part, like it's more than 65. So let's find it with Pythagoras. So 140 squared is 100 squared plus, let's call it, I don't know, let's call it a squared. A. Let's not confuse it with 9. But since we have the hypotenuse, you can solve it by subtracting. Like a squared is the subtraction between these two. Okay, so what's 140 squared? Let's do it with Pythagorean theorem. Wow, 19,600. And 100 squared is 10,000. Okay, so a squared is 29,600. And a is the root of that. So let's find that with the calculator. Excuse me. Now square root. Approximately 172.046, so 0.5 kilometers. Okay, so this is approximately 172.05 kilometers perfect. Now, what are we being asked? So the distance that B traveled. So B traveled this, which is 50, and this, which we don't know how much is it. But you know that this is 40, right? And the whole thing is 172.05 kilometers. So just subtract it. Um, this would be 132.05 kilometers, subtracting this minus this, and then you add it to the other distance that we traveled, which is 50. So the total distance that it traveled would be 132.05 kilometers plus 50 kilometers. So it's 182.05 kilometers. This is the answer of the problem. Yes, this problem was complicated, but it's not impossible. You just have to know how to read and be careful, be organized.